Did you know that recent studies have found microplastics in human blood, lungs, and even placentas? It's not just an environmental problem anymore, it's a we are the environment problem.
It's truly wild. Alex, for years, we've talked about microplastics polluting our oceans and land, but the idea that these tiny fragments are literally circulating inside us, that's a whole new level of concern. It makes you wonder how we got here and what it actually means for our health.
Exactly. Today, we're diving deep into the science behind microplastics in the human body. How do they get in? Where are they ending up? And what are the potential consequences of having plastic inside you?
We're talking about plastic particles less than 5 millimeters in diameter, that's smaller than a grain of rice, sometimes even microscopic. They come from the breakdown of larger plastics like bags and bottles, but also from things like synthetic clothing fibers or tire wear. They're literally everywhere.
And because they're so ubiquitous, our exposure pathways are incredibly diverse. It's not just one route, it's a multi-pronged invasion. Let's start with what we consume. Maya, what are some of the surprising places we're ingesting microplastics?
Oh, you name it, it's probably got them. Our food and drink are massive culprits. Take seafood, for example. Filter feeding organisms like mussels and oysters are basically little plastic sponges, and when we eat them, we're getting a side of microplastics. Fish also accumulate them.
And it's not just seafood. I remember reading about salt containing microplastics. Sea salt, rock salt, lake salt, they've all been found to contain these tiny plastic bits. You sprinkle a little seasoning and you're adding microplastics to your meal.
Right? And then there's water. Both bottled water and tap water globally have been found to contain microplastics. Some studies even suggest bottled water can have higher concentrations due to the plastic bottle itself. Plus, they've been found in honey, beer, sugar, and even fruits and vegetables likely absorbed from contaminated soil or water.
It's a bit disheartening to think that almost everything we consume could be a vector, but ingestion isn't the only way. The air we breathe is another major pathway.
Absolutely. When you think about household dust, a significant portion of it is made up of microplastic fibers shed from our synthetic clothing, polyester, nylon, acrylic. Every time you wash clothes, tiny fibers go down the drain, and every time you wear them, they shed into the air.
And it's not just indoors, outdoor air pollution also contributes. Tire wear from cars, synthetic turf, fragmented larger plastics, these all become airborne particles, especially in urban areas. We inhale these deeply into our respiratory systems without even realizing it.
So, we're eating them, we're drinking them, and we're breathing them in. It's pretty comprehensive, and the evidence of them inside us is growing rapidly. One of the earliest and most consistent findings has been microplastics in human feces, which confirmed that we were definitely ingesting them.
But the really groundbreaking stuff started coming out more recently. Studies have now detected microplastic particles in human blood samples, confirming they can actually circulate throughout the body. This isn't just about them passing through our digestive system anymore.
That's the part that really got me. Blood. It means they're not just staying in our gut, they're getting into our bloodstream and potentially going everywhere. And then there are the lungs, where microplastic fibers have been found in lung tissue, which makes sense given the inhalation pathway.
But it gets even more concerning when we talk about the most vulnerable populations. Imagine the implications of finding microplastics in human placentas. Studies have identified them on both the maternal and fetal sides, raising serious questions about potential impacts on fetal development.
That's incredibly disturbing. The placenta is supposed to be a protective barrier for the developing fetus. To think that it's being breached by plastic particles, it's a stark reminder of how pervasive this problem truly is. And it doesn't stop there. Researchers have also reported the presence of microplastics in human breast milk.
So potentially, infants are being exposed directly from their mothers. It truly highlights the extent of human exposure across the entire lifespan, from conception through adulthood. While the concentrations are generally low, the sheer ubiquity and variety of plastic polymers detected are alarming.
Absolutely. We're talking polyethylene, polypropylene, PET, PVC, all these different types of plastic. The million-dollar question, of course, is what are they doing once they're inside us? What are the potential health implications?
And it's crucial to preface this by saying that the long term effects are still largely unknown and are a critical area of ongoing research. But based on existing toxicological studies, primarily in vitro and animal models, we have some strong hypotheses. One major concern is simply the physical effect.
Right? Imagine these tiny, often sharp-edged particles causing physical irritation and inflammation in tissues. Think about the gut lining or lung tissue. And if the particles are small enough, nanoplastics, even smaller than microplastics, they might even penetrate cells and organelles, potentially disrupting basic cellular functions.
Beyond the physical irritation, there's the chemical aspect. Plastics aren't just inert substances, they contain various chemical additives. We're talking about phthalates, BPA, flame retardants, UV stabilizers, many of which are known endocrine disruptors, carcinogens, or neurotoxins. These can leach out once the plastic is inside the body.
So, the plastic itself is one problem, but the toxic chemicals it carries are another. It's like a double whammy, and it gets even more insidious because microplastics can act as Trojan horses.
That's a great analogy. They can absorb persistent organic pollutants, heavy metals, and other environmental contaminants from their surroundings. So, a microplastic particle could pick up toxins in the ocean or soil, and then when it's ingested or inhaled, it can release those concentrated contaminants directly into our bodies.
So, not only do we get the plastic and its own additives, but it also delivers a cocktail of other environmental nasties right to our cells. Our immune system also plays a role. It recognizes these particles as foreign invaders, potentially triggering immune responses.
And while an immune response is good in the short term for fighting off pathogens, chronic inflammation or a constantly activated immune system could lead to other pathologies down the line. There are also concerns about genotoxicity, meaning potential damage to DNA and carcinogenicity, but direct human evidence for these is still lacking.
It's clear why this is such a challenging area to research. There are so many unknowns. For one, we lack standardized methods for detecting and quantifying microplastics in biological samples, which makes comparing studies difficult.
And then there's the question of toxicity thresholds. What constitutes a safe level of microplastic exposure? What are the tipping points for adverse effects? We just don't know, plus, understanding long term effects requires decades of research, which is a significant hurdle.
And the smaller the particle, the harder it is to detect. Nanoplastics, which are less than 1 micrometer, are hypothesized to be even more biologically active because they can more easily penetrate cells, but they're incredibly difficult to characterize and study.
We're also dealing with individual variation. Factors like age, diet, lifestyle, and genetics could all influence how much plastic we accumulate and how it affects us. And different plastic types have different additives and properties, so their impacts could vary greatly. It's a massive scientific puzzle.
So, given all this, what can we actually do? It feels overwhelming, but are there practical steps we can take as individuals?
Absolutely, individual actions are a crucial starting point, even if they're not the complete solution. The most obvious is to reduce single use plastics. Opt for reusable bottles, bags, and coffee cups. It sounds simple, but every little bit helps reduce the demand for new plastic production.
And thinking about the clothing fibers we mentioned earlier, choosing natural fibers over synthetics where possible, like cotton, wool, or linen, can help. Or if you do have synthetics, using wash bags designed to capture microfibers during laundry can prevent them from entering waterways.
Filtering your water is another good step. Consider home water filtration systems for tap water. And when it comes to food, try to avoid plastic packaging, especially for microwavable meals where heating can increase the leaching of particles and chemicals. Choosing fresh foods over prepackaged items is generally a good idea.
These are all things we can do in our daily lives, but this isn't just an individual problem, it's a systemic one. What about the bigger picture? What responsibility do industries and governments have?
That's where the real heavy lifting needs to happen. We need policy initiatives to limit single use plastics and shift towards more sustainable, biodegradable materials. Governments need to implement stronger regulations on plastic production and waste management.
And industries need to innovate. Develop advanced filtration systems for water treatment plants and washing machines to capture those microfibers before they even get into the environment. We need investment in new technologies for plastic degradation and alternative materials that don't pose these risks.
Ultimately, addressing microplastic pollution requires a multifaceted approach. It's about reducing production, improving waste management, and developing technological solutions. And as individuals, we can support research and policy by advocating for stronger regulations and funding for this critical area.
So, the big question remains, given the ubiquity, are we heading towards a future where having microplastics in our bodies is just the new normal? What are the long-term implications if we don't tackle this effectively?
It's a challenging thought. The presence of microplastics within the human body is a stark reminder of how deeply intertwined our health is with the health of our planet. While the full extent of their health impacts remains to be determined, the current evidence warrants serious concern.
It certainly does. It underscores the urgency for both continued scientific investigation and concerted efforts to reduce plastic production, improve waste management, and promote sustainable alternatives. It's truly a defining environmental and health challenge of our time.
There's a balance between realism and optimism. We are past the point of no return for some level of microplastic presence, but we are absolutely not past the point of being able to mitigate future harm and reduce our exposure going forward. It requires a global commitment.
And an informed public, which is what we hope we've contributed to today. It's about being aware, making conscious choices where we can, and pushing for change on a larger scale.